All right, so we're going to work through these examples that have conversions between mass, moles, and molecules. Let's take a look at example one. So remember in here, we're going to use that UKPS method whenever we're solving these numerical problems. Yep, I heard the size. It's okay. All right, so the unknown here, what do we want to know? What do we want to find out? Grams of KClO3. So we're looking for mass of the KClO3. So let's look at what information they give us. All right. Are found in 1.33 moles. So they tell us that we have 1.33 moles. So that's our known. Now, our plan. How in the world are we going to get from where we are to where we want to be? So, is there a relationship between moles of potassium chlorate and grams of potassium chlorate? And if so, what is it? Wrong page flip. Okay, so is molar mass going to be helpful for us here? 1 mole of a substance equals the molar mass, right? Do y'all remember how we got those molar masses yesterday? So what do we have to do to get the molar mass of like sodium chloride? Add sodium's mass and add chlorine's mass. Where do we get those? Periodic table. Okay, so that's doable. So let's take a look at that. We need the molar mass. 1 mole KClO3. And we need to know how many grams of KClO3 that is before we can work out this problem. So let's take a moment and add up the mass of the potassium chlorate. So we're going to go, the potassium, I believe, is 39 point... Huh? Yeah, sure. All right. So the potassium is 39.1 maybe? Yeah, 39.1. We'll go with that. All right. And the chlorine is still 35.45. And then 3 oxygens, so we're going to do 3 times 16.0. All right. And when you add all of those up, okay, if you haven't got a calculator yet, go get one. All right. So we got our calculators, and I think 122.6, right? Yeah. Okay. So 122.6 goes there. Now, for the solve, we're going to use train tracks for this. We're going to do a conversion from moles to grams. And we're going to be able to do that in one step because we have one equality that will take us from moles to grams. So let's set that up. By the way, what do we always start with when we set up train tracks to do dimensional analysis? Always start with the known, yes. So let's put our 1.33 moles. I know it's been a little while since we've done this, so maybe you're still a little bit rusty with this, and that's okay. Need an L in. Oh, I put it in the wrong place. Yeah, there you go. KClO3. All right. So we're going to use this conversion. 1 mole equals 122.6 grams. And how do we figure out where to put those in the train tracks here? Yeah, what do we need to put on the bottom of the next one? Moles. Yeah, we need the moles on the bottom. So we're going to do the 1 mole KClO3 on the bottom. Then we'll do the 122.6 grams of KClO3 on the top. All right. Now let's cancel out some units here. So the moles of KClO3 cancel out. A lot of you may be tempted to stop using the compound, and in this unit that'll be okay. When we get the stoichiometry, though, in a couple of units from now, it's going to be very important that you not only list the unit, like the moles, but also the identity of the compound. I'm just going to keep writing the identity of the compound as we go through this, because that's just how I'm going to do it all the way through this and stoichiometry as well. So 1.33 times 122.6, I'm going to guess that it's somewhere around 160. Has anybody done that in your calculator yet? What'd you get? 163.05. And how many significant figures should we probably keep? Probably keep 3. So the conversion's not going to be what limits us, the initial number of significant figures. So I'm just going to go 163. Yep, that's right. There you go. Questions? Yes.
How did she get to 163?
So we multiply the numerator, and then we divide by the denominator. If there were more things in the denominator, we'd multiply them by each other. Then we'd do the numerator divided by the denominator. Yeah. There was just a 1 down there. So all we had to do is 1.33 times 122.6, and then divide by 1, which doesn't change the value.
So to do the whole problem, you just have to find out how many moles are in KClO3, and then convert it from grams to moles.
Yeah, or how many grams? I think you meant to say how many grams are in a mole. Yeah, you had to add that up. And by the way, that quantity of how many grams per mole, going to drive this home, is the molar mass, the mass of a mole. All right. Example 2, how many moles would be found in 143 grams of water? Just comparing this to the last problem. Last time I asked you to go from moles to grams. This time we're doing the opposite of that with a different compound. So you'll see how that works too. All right. So the unknown here, we don't know how many moles. The known, we know how many grams, 143. All right, in order to go from grams to moles, we need to know what quantity. What was this called? The conversion between moles and grams. I heard somebody whisper it, I think. Maybe. The mass of 1 mole of a compound is the molar mass. Here, we got to know the molar mass. Okay. All right. We don't have to add that one up today because we did it yesterday. So yesterday we added up the mass of water and we got 18.02. So we'll just pull that over here and do that. 2 hydrogens and 1 oxygen. All right, then we'll set up our solve and start with the known. What goes on the bottom of the conversion? Is it the 1 mole of water or the 18 grams of water? 18 grams of water, and then whatever goes on the top must be equal to the 18 grams of water, so that's going to be the 1 mole of water. By the way, one acceptable way to shorten mole is to do MOL instead of MOLE. It'll save you 1 letter. All right, math on this. We're going to do 1.43 times 1. Doesn't change the value, so it's 1.43, and then we're going to divide by 18.02. What? Point? Oh, why did I put a decimal in there? Good call. let's see, 143 divided by 18. Let's go 7 point something. 7.935. So 7.36. That's what it would round up to. 7.93. Okay, so 7.94. So anybody else confirm that? 7.94? Okay, cool. Huh? Oh, that's not grams, that's moles. All right, yep, grams canceled out, left was moles. I'm going to box the answer in so everybody knows that that is the intended answer there. Questions?
Can you get back to the plane real quick?
Yeah, sure. The plan is just, what I want you to list on these conversions is just list the conversions that you need to, or the equality you need to do the conversion. And on these, they've been one step. All right, example 3 is going to take more than one step because example 3 asks us how many molecules of water are found in 25 grams of water. So last time we started with grams and we were able to go to moles. So this is going to be one more step than that because now we want to go to molecules. Does anybody remember from yesterday how many molecules are in a mole? Yeah, I heard 6.02 times 10 to the 23rd. I heard Avogadro's number. You're both correct. And eventually somebody's going to say Avocado's number, and then, and then that's going to stick. And you're just going to be calling it that for now. But it's Avogadro. Anyways. All right, so the unknown here is molecules of water. And the shortest way I've figured out to abbreviate molecules is MCLS. If you try to do MOLS, you might get it confused with what? Moles. So I do MCLS, or you can do MOLEC, or just write out molecules all the way. All right. So the known is that we have 25 grams of it. And then we're going to list the two conversions in our plan that we'll need to get there. So we know the molar mass of water already is 1 mole of water equals 18.02 grams. And then we also know that 1 mole of any substance is 6.02 times 10 to the 23rd molecules or particles or atoms. Just depends on how the what the most basic version of that substance is. All right, so our most basic particle is. All right, so let's set up our solve. We'll start with the known just like we did last time, 25 grams. And what do we do first? Okay, we've already got the 25 grams. Yeah, so we're going to do the 18 grams on the bottom just like we did here. We're going to convert to moles. Grams cancel out. Now we want to get to molecules, so we'll look over here at our plan, and what should go on the bottom of the next conversion? Yeah, we'll do the moles on the bottom. All right, so when we multiply this out, we'll multiply everything in the numerator, then we'll multiply everything in the denominator and divide the numerator by the denominator. All right, so after calculating and correcting this to be 23rd instead of 24th, here's the answer.